So hello, in this video I'm going to speak about intelligent agents. It's going to be the video one regarding intelligent agents. So the first question that we must ask ourselves is, what is an agent? So we can see here a graphical representation. We got the agent here inside this block. So the agent receives, it uses sensors to perceive the environment. So it receives percepts or stimuli from the environment, and based on that, is going to take decisions and is going to act on the environment through actuators. So these actions are going to have consequences in the environment. So according to Russell and Norwich, an agent is anything that can be viewed as perceiving its environment through sensors and acting upon the environment through actuators. So a very good example is when you are driving a car. Considering that you are driving a car, and of course we have a lot of sensors. We as agents, we have sensors for eyes, ears, our hands. So we based on this information, the driver is going to make a perception, and then is going to make a decision about the future, the action is going to take, and of course is going to use or give that orders to the actuators. You can use these hands, these feet, these pedals, driving, the driving wheel, of course, etc. So another definition, according to Michael Wooldridge, an agent is a computer vision that is situated in some environment and that is capable of autonomous action in this environment in order to meet its design objectives. Okay, this is another definition. And examples of agents, of course, we have humans, is the first one, and then we have animals, we have robots, for instance, this mobile robot to clean your house is a perfect example of an agent. And the thermostat. The thermostat is a device that exists in every heater. For instance, this heater here, it gets incorporated a thermostat. The thermostat is a device which has incorporated a sensor who measures the temperature that you want to reach, and also a switch that is going to turn the heater on or off. So also software agents, softbots are an example of agents. So some definitions regarding agents are the agent function and program. The agent function is a mathematical way of describing the agent behavior. How can we do that? That's the question. Okay, so for each perceived or perceptual sequence, which is represented by this P is with star, the function maps the sequence to a certain action that is going to be executed. Of course, the agent program is executed in a computation system to implement the function f. A good example about an agent is the autonomous driving that you can see here. The cars have a lot of sensors and actuators. So the sensors, the agent perceives the environment, and it is important to understand or to identify a lot of characteristics. For instance, which is the environment in this case, which are the sensors used, which is the perception, which is the perception sequence, what is the agent function, and what are the actuators. For this example, it is easy to understand the environment. Of course, part of the environment is defined by the road, by other cars, the pedestrians, the traffic signs, animals that may appear, sensors. We can have examples of sonars, cameras, radar, velocity sensors, etc. And actuators, the driving wheel, the brake pedals, the accelerator pedal, etc. So one example, a classical example, is the vacuum cleaner example, which is proposed in book of Russell and Norwich. And so in this case, the perceptions are the two locations. Okay, the vacuum cleaner is either in square A or in square B. It has two states, each square. It is dirty or clean. So the action is move to the left, move to the right, sack the dirt, and in the case of the irregular operation, the no operation, it does nothing. So a simple and partial tabulation of the agent function to do this purpose means to clean the square if it is dirty and moves to the other square if the one where it is located is not dirty. So there's a lot of ways to do that. For instance, if A is clean, it should move to the right. If A is dirty, it should sack. If B is clean, it should move to the left, and etc. These are a possible table for the function. Okay, of course. One important question is what makes an agent intelligent? So the previous table can be filled in several ways, but what is the best way? Which is the best question? So this is the real questions that make the agent intelligent or not. So in the next video, I'm going to address the rationality concept. And to conclude this presentation, this is the two references that I use, Russell and Norwich, Artificial Intelligence, a Modern Approach, and Ulrich, An Introduction to Multi-Agent Systems. Okay, and with this, I'm going to conclude the presentation. Thank you very much for watching.